Okay, in this lesson we're going to have a look at Unit 6, Chapter 6, Trigonometric Identities, and we'll be looking at Proving Identities Part 2, and we're specifically going to be looking at proving identities that involve factoring. So this is from Section 6.3 in your text on proving identities, and again the focus is going to be on proving identities which involve factoring. So let's quickly review again our double angle identities, because we do need to use these again. Our difference identities and our sum identities. And of course we have our Pythagorean identities as well. All of these identities are again given to you on your public exam, so you don't need to worry about memorizing any of these. We just need to know how to use them, of course. So let's jump right into a couple of examples here. Prove each identity. Well, the first one, I got secant squared plus tan squared times secant squared equals secant to the fourth. The very first rule in factoring is to remove a common factor, if one exists. Here, if you look closely at the left side of the equation, you can see that secant squared theta is a common factor. So if I remove that as a common factor, I get secant squared theta outside of 1 plus tan squared theta. Got to equal secant to the fourth theta. Now immediately I recognize my 1 plus tan squared right here as an identity. 1 plus tan squared is equal to secant squared. So I can replace 1 plus tan squared as secant squared. And you can see now I'm pretty much done here, because secant squared theta times secant squared theta is secant to the fourth theta. And that's exactly what I have on the right side. So I'm done. Pretty simple once we remove the common factor. Let's have a look at the next example here. This one is done in a similar way. I've got cotan x minus sine squared times cotan. Again, we recognize that from the left side here that I can remove a common factor of cotan x. So I got cotan x outside of 1 minus sine squared x. Oops, I wrote theta. Let me fix that. So I simply remove a common factor of cotan x equals cosecant cubed times cosecant x. Well, I look at this and I again recognize, because I've done a lot of these, that 1 minus sine squared can be replaced with cosine squared. So let's rewrite the identity now as cotan x times cosine squared x equals cosine cubed x times cosecant x. Don't have the same thing on both sides yet, so maybe what we need to do is rewrite everything in terms of sine and cosine. That's a strategy for proving identities. So cotan is cosine x over sine x. Got to learn that and know that, of course. Cotan is cosine over sine times cosine squared over over 1. Got to equal cosine cubed x times cosecant is 1 over sine. On the left side, when I multiply cosine by cosine squared, I get cosine cubed over sine x times 1, which is sine x. So I end up with this on the left side. On the right side, when I multiply the two fractions, I get cosine cubed x over sine x. So again, I've now proven the left-hand side equals the right-hand side, so I've proven the identity using factoring, because I had to remove a common factor of cotan x from the beginning. And again, notice that, I got the fact that 1 minus sine squared equals cosine squared from the Pythagorean identity right here. If I solve this for cosine squared theta, I get 1 minus sine squared theta, right? And that's where I replaced 1 minus sine squared with cosine squared. Okay, let's have a look at another example here. Prove this identity. Okay, now we're going to have to use our double angle identity for tan 2 theta. And I've written this one up here in the corner for you. Tan 2 theta equals 2 tan theta over 1 minus tan squared theta. So I got 1 plus tan x. Tan 2x, well again, I'm going to replace that with 2 tan x over 1 minus tan squared x. Got to equal 2 tan x over 1 minus tan x. Now if you look at the two sides of the equation, you got to start thinking, how am I going to get both sides equal? What do I already have? Well, I got a 2 tan x and I got a 2 tan x, so that looks pretty good. But my 1 plus tan x got to disappear from here somehow, and I got to be left with a 1 minus tan x. Well, if you recognize this as the difference of two squares, I think it's pretty easy from here. 1 minus tan squared can factor. I got 1 plus tan x times, leave the 2 tan x as it is because we already got that on the right side. 1 minus tan squared is 1 minus tan x times 1 plus tan x. Got to equal 2 tan x over 1 minus tan x. If you look closely on the left side, my 1 plus tan x can cancel. This 1 plus tan x can cancel with this 1 plus tan x, and I'm simply left with 2 tan x over 1 minus tan x equals, and it's the exact same thing on the right side, and I've proven the identity. But again, it required to use a factoring in order to do that. I factored my 1 minus tan squared using the difference of two squares, which is 1 minus tan x times 1 plus tan x. The 1 plus tan x's will cancel here. And remember, I can cancel things in the numerator and denominator if what you're canceling is multiplied by everything else. The 1 plus tan x is multiplied by this. The 1 plus tan x is multiplied by this. And the 1, of course. So I can cancel those two. Okay, let's have a look at example 3. Prove the identity. Again, involving factoring, hopefully. So if I look at it, just by looking at it here, there's no common factors that I can remove. I got a cosine 2x and a sine 2x, so I know I got to get rid of that. So let's see if we can get rid of those two. So let's rewrite this, I suppose, in terms of sine and cosine as well, because you see I got all sines and cosines on the right side, on the left side, so we don't. So let's rewrite cotan as cosine over sine. Subtract cosecant, which is 1 over sine. Got to equal, okay, let's see what we got on the right side here. Cosine 2x, I'm going to use this one up right here. And I know we got 3 choices, and sometimes you just got to make a decision on which one you want to try. If it doesn't work, you go back and you try something else. But I'm going to use this one here. 2 cosine squared, x, subtract 1, minus cosine x, over sine 2x is simply 2 sine x, cosine x, plus sine x. Okay. Not seeing a whole lot here that will help me, but the left side I know I can add those two, or subtract in this case, because I got a common denominator sine x. So I'm looking for cosine x subtract 1, because when I subtract the left side, that's what I get. Cosine x subtract 1 over sine x. So I guess, how can we get that from the right side? Well, maybe if we took our numerator here and we rewrote it as 2 cosine squared x minus cosine x subtract 1, we may be able to factor that in order to simplify it. Let's see if we can factor 2 cosine squared, subtract cosine, subtract 1. You want to think of that as a quadratic. It's the same as, and I'll just do it like this. Let's let n equal cosine x. If I let n equal cosine x, I get 2n squared, subtract n, subtract 1. Let's factor that if we can factor. And I'm pretty sure this factor is pretty nice. 2m and m, 1 and 1. I want a negative 2m. So let me just double check my factoring here. And again, most students have different ways of factoring. I'm not going to try and teach you my way of factoring. I factor without using decomposition, but if that's what you're used to using, you go ahead and use that. Some of you may be using the box method that you learned in level 1. That's okay as well. I use a method called trial and error. And I can factor fairly quickly with that. But I always want to check my work. 2m times m is 2m squared. I got a minus 2m and a plus 1m is a minus 1m, so there's my middle term. And I got a plus 1 times a negative 1 is a negative 1. So I factored it correctly. But don't forget now, we let n be cosine theta. So I really got 2 cosine theta, or 2 cosine x, sorry, plus 1 times cosine x subtract 1. Now in my denominator, I can factor out a sine x. So let's do that at this point. I'm going to get sine x outside of 2 cosine x plus 1. And I'm hoping that you see that that's going to be very beneficial to me by doing that. Let me show you why. Cosine x subtract 1 over sine x equals. I just factored my numerator to be 2 cosine x plus 1 times cosine x subtract 1. Forgot my bracket there. Over Now, when I remove my common factor of sine x a minute ago, I'm left with 2 cosine x plus 1. My 2 cosine x plus 1s will cancel. Both of their factors in the numerator and denominator, they're gone. I'm left with cosine x subtract 1 over sine x equals exactly the same thing now on the right side. So I've proven this identity, and it required the use of factoring twice, actually, on the right side of the equation. Okay, let's have a look at one more example here. Prove the identity. 1 minus 3 cosine x minus 4 cosine squared over sine squared equals 1 minus 4 cosine over 1 minus cosine. Okay. Left side again, I immediately recognize that as a quadratic. It's not written in descending order, but that's okay. I'm going to write this as 1 minus 3m minus 4m squared. Again, I'm letting m equal cosine x, just to make it a little simpler for factoring. Now I want to factor that exactly the way it is. So I'm going to use my 2 sets of brackets again. 1 and 1. I'm going to use 4m and 1m, and I'm going to use a negative and a plus. And I'm pretty sure that's going to work for me. Now I'm going to double check. 1 times 1 is 1. I got a 1m and a negative 4m is a negative 3m. There's my middle term. And a negative 4m times 1m is a negative 4m squared. So I factored it correctly. Now don't forget, though, of course, m is cosine x. So it's really 1 times 1 plus cosine x. So let's go back and fill that in. 1 subtract 4 cosine x times 1 plus cosine x. Got to equal 1 minus 4 cosine x over 1 minus cosine x. Now at this point, you may look at this and decide, what else could I do with this? Oh, of course, I got to write over sine squared. What else can I do with the left side in order to get the right side? Well, I would immediately recognize that my right side got all cosines. My left side still has a sine squared there. So I got to somehow get rid of that, because the right side doesn't have any sines. I also recognize that I got a 1 minus 4 cosine, and I already got a 1 minus 4 cosine, so that's looking pretty good. But I got a 1 minus cosine here, and I got a sine squared here. Well, sine squared is 1 minus cosine squared, so that might help me. So let's replace, and again, getting rid of the sine squared. Again, you want to look at the two sides and see where you are and where you need to get. So I need to get rid of my sine squared, so I'm going to write as 1 minus cosine squared. Now, 1 minus cosine squared, though, does factor. It factors nicely because it's the difference of two squares. So it becomes 1 minus 4 cosine x times 1 plus cosine x. I can't do anything with that. But my denominator I can factor as 1 minus cosine x times 1 plus cosine x. The 1 plus cosine x's will cancel here. And you can see what you're left with. You're left with 1 minus 4 cosine x over 1 minus cosine x, which is exactly equal to the right side right there. So I've now done this one as well by factoring. All kinds of different examples you could encounter here. I've just thrown in a few here as examples that you may encounter, something along those lines. So let's have a look at the key ideas. To prove a trigonometric identity algebraically, you separately simplify both sides of the identity into identical expressions. That's what involves proving a trigonometric identity algebraically. And some strategies that we used here in this lesson was that we used known identities to make substitutions, and also we factored